Hello, Mrs. Middleton here to introduce you to how natural disruptions relate to the ecosystem. We have a lot to cover, so let's get into it. A natural disruption to an ecosystem can have incredible consequences and can be as great as or greater than human-made disruptions. You can think of a volcano eruption like Mount Vesuvius next to Pompeii, and some might think of that as an event or disruption to the environment that had huge consequences on the people and the environment. Some might even think bigger than man-made disruptions. When we talk about natural disruptions and how they tie to Earth's system processes, they can be considered either periodic, episodic, or random. Periodic changes can be rhythmic or repetitive in predictable intervals. For example, the Milankovitch cycles, which I may be pronouncing that wrong. I looked it up through YouTube, and there are some British people saying it and some other people saying it, but as far as I can gather, it's pronounced Milankovitch. So the Milankovitch cycles, which are the three movements of Earth as it revolves around the sun, are predictable and can be linked to times of increased or decreased glaciation. In relation to time, Milankovitch cycles are a very long-term cycle taking upwards of 400,000 years. These cycles, which include Earth's orbital distance from the sun, Earth's tilt, and Earth's wobble, can bring great disruptions to Earth's ecosystem if the conditions are conducive to creating glaciers. Natural disruptions can also be episodic. Episodic natural disruptions may occur more frequently, like California's yearly forest fires. Note that I am speaking about naturally occurring forest fires, not man-made or anthropogenic fires. Certain trees and forests are dependent on the natural destruction and regrowth that occurs from forest fires. We can count on California having a forest fire at least once a year, so it is considered episodic. It's a much shorter time frame than a periodic natural disruption. The final Earth system process, when we are talking about natural disruptions, might happen randomly. Scientists cannot count on or predict when these events will happen. An example of a random natural disruption would be a volcano. Scientists may be able to tell that magma is moving within the chamber in an active volcano, but they cannot predict or count on the eruption happening within a certain time frame. Even with its disruption to an ecosystem, a volcanic eruption is still considered a process of Earth's systems that can be beneficial to an environment as much as it can be detrimental. Because we're talking about natural disruptions to ecosystems, we must talk about climate on Earth over time. Most of the time, when you hear about climate change or are talking to someone who is extremely passionate about it, you will have this image brought to the forefront. This image is not wrong. Earth's temperature has been increasing since the 1880s. If we zoom out to more of Earth's history, it still looks pretty dismal. But remember, the Earth is 4.6 billion years old. There is so much more history than the past 1,000 years. Here, we've backed up a little more. You can see that the little red area on the graph to the far right is where we are today, and that there have been times on Earth when the climate was much warmer than it is today. In fact, the greenish-blue line cutting through all the data is showing that on average, this current time in Earth's history is much cooler than in the past. The final graph I want us to look at is demonstrating how climate has changed a lot through Earth's history. The top graph is showing us that carbon concentration and temperature has pretty much mirrored each other throughout history. Just like the graph on the last slide is demonstrating how changes in carbon dioxide affect the climate of an area, there are other factors that can change Earth's climate. Things such as landmass location, volcanic activity, and ocean circulation can greatly affect Earth's climate naturally. Glacial activity can also affect the Earth's climate, but it can affect so many other things too. On Earth, if there is ever an increase in glacial ice, there will be lower sea levels. If there is a decrease in glacial ice, sea level will rise. The image above is from a YouTube video by Science Insider showing what North America would look like if all ice on Earth would melt. You can see that Miami, New Orleans, San Diego, and Charleston are completely underwater, with the ocean creeping up the Mississippis towards the Great Lakes. Back during the Cretaceous time period, about 75 million years ago, there was a seaway running through the center of North America. It was a warmer time period in Earth's history, and because of that, we can see that a lack of glaciers increases the amount of water in the ocean. Due to some of the environmental changes we just talked about, habitat will have huge changes as well. A whole ecosystem might have to rebuild itself, and this may change the structure of the ecosystem. On a large scale, we can see these changes in mass extinctions of several organisms, with a new top predator rising from the chaos that was the natural disruptions. This image of the geologic timescale shows the evolution of biology as natural disruptions alter and change the habitats from very basic forms to much more diverse forms we find today. We can also see it at a much smaller scale when a small area is affected by some disruption and a forest begins to rebuild itself. We will talk more about succession in the future. Natural disruptions can also affect how a population moves. For example, after a forest fire, several species may move from one area to another local area that meets their needs, and then once the area has healed itself, those species might move back into its original area. On the other hand, climate change is currently changing the movement of trees that need to grow in colder conditions. Those trees that are used to colder temperatures have been moving up into higher elevations so that their limiting factor, which is temperature, is optimal for them. Climate change is typically slower than a forest fire, so this would be considered a long-term migration. Thank you for listening to tonight's episodes of Apes in the Home. Please feel free to email with questions or write those questions down and bring them to class to discuss. Have an excellent rest of your day.